Imagine you have a wrinkled piece of paper and you just want to draw a regular square. You can try as best as you can to mark it and make it all straight and perfect, but once you flatten it back out and take out the wrinkles, you may notice that the square may not be perfectly square. It could be a little bulged outward, it could be rounded on the corners or whatever it may be, and that's exactly what happens if you don't calibrate your fiber laser. To be more specific, galvo lasers use F-theta lenses. F-theta lenses are great because they distort the light and laser on the outermost edges of the engravable field. That just gives the software a linear relationship and correlation between your movement and the galvo mirror movement. Without F-theta lenses, that distortion isn't there, so that relationship is going to be exponential. The galvo moves a little bit and it's going to shoot way over to the side. It just makes things a little bit more complicated on the back end, so F-theta lenses are our friend. Today we're going to be covering 9-point correction, which is a built-in calibration feature in LightBurn. LightBurn is a software we use on all of our lasers, and of course everything that I'm going to be covering today is also in our fiber laser training handbook. To start off, we use a 12 by 12 inch black piece of construction paper, but you can also use cardboard. And then honestly, the most important step before you get started is making sure that you're at optimal focus. If you begin to do calibration out of focus, well then all of your calibration will be completely useless because you're going to be running your laser at focus. Now with our lasers, there are two features built in to automatically find optimal focus, but I also have a focus stick here set at my specific optimal focus height. Now that I found my focus and my machine is on, computer plugged in with construction paper flat on the workbed, I can now move over to LightBurn. Now I'm specifically using LightBurn 1.7.03, but the same steps and everything are on LightBurn 2 or anything above this. At the top, you want to navigate to your laser tools, click on that, and then scroll down to Calibrate Galvo Lens. Then we just move over to 9-point correction. Easy, because it is that easy. With our pop-up, first thing we want to do is enter our engravable work area. Now I have a 220 by 220 lens in there, so this is correct. And then we'll want to enter the size of the box to output, usually 86%. Whatever's default is just good. Hit next. Now this laser is an Edge 50, so it has a 50 watt source inside. Your laser may be different or different wattages, so scale accordingly. We have a speed of 300 millimeters per second with a power percentage of 20. It's always safe and always a good play to actually lower the percentage to where you don't see anything at all and gradually increase if you have to. First thing I'll do is hit frame to make sure that my construction paper is within my workable space. And already automatically you can see on the outsides of the square, it's bulging a little bit. It's not a perfect square. That's where that correction is going to come into play because the lens is distorting it and it looks just a little bit round. Now keep in mind the square may be a little bit offset from where you originally saw the red dot, and that's because we also need to do red dot calibration, but we'll do that after the 9-point. Now a huge key important part of this setup is you want to make sure that you can see every single line intersection. It should look like this where you can see the corners on all four sides. Usually or sometimes they don't come out as prominent and you may have to do a few passes to really get that engraving and get where you want, because ultimately those intersections are where we're going to get our ruler or calipers and measure from to base our whole calibration off. So in my case, it came out perfect. First try, first pass, I can see all the corners. It's very visible. The contrast is high. I can take measurements from every point, whatever I need. But if that's not the case for you, run a few more passes or up the power if need be. Now that I've confirmed I can see everything, I can now touch it. Do not touch it if you can't see everything before you run a few passes. Now this could be a little tricky if you don't look for all the details. There's two things that can throw you off. You're gonna be looking for the very bottom of the dragon and then the side where the tail kind of whips around. Now in my case, I'm gonna select this one because I can see the bottom is here and then the tail is there. Not to get confused with this one, which is very similar, just flipped. Once I have that selected, I'll hit next. And now this is where the easy part comes in. It's gonna have everything laid out for you on the screen. You just have to take those measurements at the points that it's asking. All right, let's see if we can do this. So this is gonna be a little bit of an exaggeration, but bear with me. This is gonna be the center square or cross right in the center of that giant square that's gonna do. Now, the way I'm drawing it is it's bulged outward, but yours can be bulged inwards, either top or sides. This is just one of the many examples that could possibly happen. Now, this is going to be the top center dot. Say that our dot on this side is going to be lower. Well, most people think, okay, I need that measurement. I'm gonna put one end of my caliper here and one end here. But really what that does, you get a diagonal measurement. That diagonal measurement is not what we want. We want an absolute horizontal measurement, which would make our dot up here. Now, obviously our dot isn't up there, so how are we gonna do that? Now, I use a ruler, so this makes it a whole lot easier, but the center square is going to have an absolute vertical and horizontal lines. Those are going to be our reference points. That's what I'm gonna base my ruler off of to make sure that it only moves in one axis at a time. I'll draw a little coordinate system here. So LightBurn is asking me for dimension 1, which is gonna be this top horizontal distance, which means I can only move in my y-axis only. If I were to angle it or move in my x-axis at all, that measurement, I can measure it right here on this tiny scale, and I'm going to be about 45 millimeters compared to the absolute horizontal distance of about 40. So that's a 5 millimeter difference on this small scale, which translates to something much bigger on, say, the actual calibration. That's why this matters so much. And the reason being is just simple trigonometry. We have a point here and a point here. You're measuring, or a lot of people measure the hypotenuse, which is not the measurement we want. We want the measurement here, which is either our adjacent or opposite angle depending on how you're looking at it. This dimension is always going to be a lot smaller than your hypotenuse, but that's the right dimension that we want for the computer to accurately scale and do everything we want with our 9-point calibration. If the diagonal dimension is taken, everything will be thrown off. So how do we do that? Like I said, we're gonna wanna use that vertical line as our absolute vertical constraint. So I can just put the end of my ruler right up against that line and trust that this is a vertical constraint, and I just move it up until I can see that that dot intersects right there, and that's the measurement I'm gonna wanna take. So you'll do that for 1, 2, 3, 4, 5, and 6, and then LightBurn will ask you for the vertical dimensions. Let's run through one of those. Say LightBurn wants you to get this vertical dimension. Now, like I said, you don't wanna go diagonal at all. Since we're going vertical, we can only move in the x-axis, which means only this way. And since we have that horizontal line above us, we're gonna use that as our absolute reference. So I'm gonna put the end of my ruler there and only slide against that line and find my points, because my point will be right there. I'll slide over, my point will be right there, and I'll slide over once more. And of course, this point will be far down here, which means it needs a whole lot of correction, but we can just stop right there and record that data point. So your ruler or calipers are only moving in one dimension at a time. That will ensure that you're getting the either vertical or horizontal distance for the proper calibration. So take this dot for another example. We are doing our horizontal distances. Okay, I'm gonna use my vertical line as my horizontal constraint and only slide up and down from there. We have a dot right here, so I'm gonna put the end of my ruler there, and I wanna line it up with this dot. However, I'm gonna have to slide my ruler down a little bit on that line to get the dot close enough to my ruler or caliper. So the caliper is a little bit trickier because you can just put one end of the jaw there and one end of the jaw there, and it's really tempting to do that, but you're gonna get that diagonal dimension and not the horizontal or vertical dimension. So just be very careful of that. So it's asking for distance 1. Distance 1 is gonna be my top left square at the very top edge. 113.5 millimeters. So I'll type in 113.5. Cool, now we can move on to distance 2. Distance 2 will be the top edge on the top right square. 113.2 millimeters. And now distance 3, which is gonna be the top edge of our bottom left square.
And now we're gonna do the same thing for all the rest of the dimensions.
Now that I did those, I can hit next, and it's gonna ask me the same exact thing, but now for the vertical sides. And if you get confused or you messed up the orientation, just keep in mind that the LightBurn logo shown on the screen should match up to how you're viewing it on your workbed.
Now we wanna do the same exact thing as before, but with the vertical dimensions.
Then I'm gonna hit next. And well, there it goes. It gives me all of my corrections, your scale, bulge, skew, and trapezoid without ever having to do anything other than just measure and type in numbers. And then you hit done, and then now your laser should be calibrated. Now that the laser's calibrated, we want to calibrate our red dot next. All right. This is our red dot, and then this is our laser beam collimator. Now, since they both funnel through the same hole to the galvo head, if the red dot isn't perfectly aligned here hardware-wise, then when you go to frame something, the square might be here, but the actual laser engraving will be somewhere over here or off a little bit. Red Dot Calibration fixes that. It tells the galvo mirrors, hey, offset this much so the red dot matches where the laser actually fires whenever you frame. So we're gonna hop right back on LightBurn. We're just gonna make a simple little square, switch it to line mode. Then we're gonna hit P, center it in our workspace. I'm gonna come up to the top and I'm gonna dimension it. I'm gonna want, say, a 4x4 inch square. Now we're gonna wanna engrave that 4x4 inch square and then frame it to make sure that the red dot aligns right on top of where the laser engraved. And before that, just adjust your settings in case anything's crazy, like mine. We don't wanna do it at 100% power. We'll lower it down to 20. I'm gonna hit frame and I can see that it's supposed to be right in the center of my workpiece. I'm gonna hit start, it's gonna do its thing, and then once again, just like calibration, if you don't see it and it's not readily visible, run it a few more times, increase passes or increase power. Now that I've done that, it's not quite as bad as it could be. It actually measures up pretty nicely. So after it engraved, hit frame again, and now I can visibly see that the square is a little bit off-centered of where it actually engraved. Illustration time. Now imagine the solid line is going to be that square that I just engraved. Now the dotted line is going to be my red dot after I hit frame. Now clearly they're not lining up. This is just an example. Yours might look completely different or it might be perfect. Now there are two features to adjust your offset. There's going to be one which is going to be just an offset, so we can shift the entire box over, because clearly we want to match it up with this line. We want to move it over and we're going to subtract in our X offset. The other tool to adjust those offset is called scale. Now that shrinks or expands our red dot. So in this example here, I clearly want to move this red dot over to the left. So we're going to have to subtract on the X offset. And clearly in the Y, it's a little bit too big. So we're going to have to decrease or subtract that Y scale. Now this is where it can get tricky. Remember, the solid line is where it engraved and the dotted line is my red dot. What if I get two edges perfectly lined up, but the others aren't? Well, you're gonna have to scale both sides. But if I were to scale both sides, they scale linearly right in the middle of that red dot. So that doesn't mean they're gonna scale perfectly down and this side's gonna remain on that edge. No, it's going to scale something like this. So that side is going to decrease and so is that side. Now, this side no longer matches up with this edge. So you have to then offset to the left a little bit, and then once again, you'll have to offset up a little bit. So it's gonna be a game of cat and mouse. You're gonna have to adjust scale and then offset, move back and forth, up, down, whatever it may be to get that perfectly lined up. So by looking at mine, I can see that my square has shifted the red dot ever so slightly upward from where it's currently engraving. That's gonna be my Y-axis. So I'm gonna go over to LightBurn, click on device settings, and then up here at the top right-hand side is gonna be my red dot offsets. Now I'm gonna wanna adjust my Y-axis. So right here on Y, it's currently set to 0.45 millimeters. I'm gonna wanna bring it down. So I'm gonna decrease this offset ever so slightly. Let's say 0.3. I'm gonna hit OK and then frame again, and then I'm going to look at it and it's gotten significantly better. There you go. And then you're just gonna keep going back and forth, shifting the numbers ever so slightly, either positive to make it move upward or to the right, or you're gonna decrease the number to bring it down or to the left. So this is where it gets interesting. The top part of my square is dead on, that's perfect. However, the bottom part of my square is still a little bit off. And if I continue to adjust that, then I can get the bottom part of my square to line up, but my top part will then no longer be lined up. So to adjust that, we go back into our device settings and specifically look at our scale. We're gonna look at our scale for the Y-axis. I'm going to increase it a little bit and go back and check to make sure everything, oh my gosh, that was a lot of bit. We're gonna go back down from that number. The scale just controls how big it gets, right? That's if it's too small, regardless of how many times you move it back and forth, up the scale. Or if it's too big, no matter how many times you move it back and forth, decrease the scale. Okay, now I have my Y-axis aligned. Now I'm gonna move on to my X. Well, honestly, it looks pretty dead set on the right-hand side. The left side is just a little bit, it's falling too short, which means I have to scale it. Now I adjusted the scale and it's slightly bigger. However, now the right-hand side, it's slightly out of the square, and same with the left-hand side, it's slightly inward. So all I'm gonna do now is change the offset to move it to the left-hand side. And that should line everything up. So let me go back and go to my offset, but this time in my x-axis, I wanna move to the left, so we're gonna decrease that number. We're gonna go to, I don't know, 18? And then check again. Just a little bit more. And well, that looks pretty spot on. So now your laser's ready to go. Wherever that red dot is framing, you can trust that the laser is gonna fire exactly where you set it because you just did red dot calibration. And if you were to engrave on the outer sides of your workspace, then you can trust that whatever you see is actually going to happen and not some weird bulged or weird looking distorted shape because you did the 9-point calibration.